So this is the start of topic 6, and topic 6 is all about exponential and logarithmic functions. Okay, we're going to start out just looking at what an exponential function looks like. What do you see in the word exponential? What word do you see?
Exponent.
Exponent. So all we're saying, and we have a function that's exponential, is that your exponent is where the variable is at. Okay, and we actually graphed these simple ones in Algebra 1. So, in fact, that's what I'm going to be doing with my Algebra 1 kids next week. So when it says to graph this function, this is in function notation. That's why it says f of x. If you don't like function notation, you can change that. And so you can just say, well, that's y equals 2 raised to the x. You can replace the f of x with a y. That's fine. Just like before, you're going to make a table of values. And because x is the exponent and it's missing, we're going to fill in values for that exponent, or for x in this case. There will come a time where we plug in values for y and figure out x, but in this case, we're going to plug in values for x. So I'm just going to pick out, I want to do negative numbers and I want to do positive numbers. And I'll just go with 4 to start with. And if we can get the general shape of the graph out of 4 values, that's all we need to put in our table. I would say put a minimum of 3 values in your table. Okay, always do at least 3. Put some positives in, put some negatives in. Okay, you got to go back to your Algebra 1 days. When I put a negative 1 in here and I have y is equal to 2 to the negative first power, what does a negative exponent, we actually did this earlier in the year, what does a negative exponent do to a term? It does not make it negative. What does it do to it?
Doesn't make it a decimal?
Makes it into a decimal. That's right. We evaluate a negative exponent by creating a fraction. We say 1 over 2 to the first power. 2 to the first power is just 2, so this would be 1/2 for a value. 2 to the negative first power is a half. If I put a 0 in there, so I said y equals 2 to the 0 power. What is anything to the 0 power?
0?
Nope.
2. Stays the same.
Wait, does it go down by 1 or?
Okay, it doesn't go down by 1. Let's
Negative.
see, where can I do this? Let's look at, I'll go off the, I gotta stay on here. I'm going to stop this a minute. I'm going to go back and say, all right, if we're looking at exponents, 2 to the third power, what does that equal? 8. 2 times 2 times 2, right? That equals 8. If I drop the exponent by 1 and I say, not up by 1, but down by 1, and I say 2 to the second power, what's 2 squared?
4.
4. How much did that go down by?
4.
Okay, it went down by 4. How else could you describe the decrease? It's half of it, right? So if I drop the exponent again, 2 to the first power equals 2. Did it go down by 4 again, or did it get cut in half? It got cut in half. So each time you can see the value is dropping by half. So 2 to the 0 power,
Plus 1.
if I cut 2 in half, what do I get?
1.
I get 1. Anything to the 0 power equals 1. That's a rule for exponents. I can take 100. If I raise 100 to the power of 0, it's going to equal 1. If I drop the exponent again and I get into the negatives, 2 to the negative first, we already put in our table. What did 2 to the negative first evaluate to?
2. Wait, what?
What was in our table for 2 to the negative first?
1/2.
1/2. Did that cut in half again? Yeah. So that's what's happening each time you decrease the exponent by 1. Your value over here is being cut in half. Will this value over here ever become 0
No.
or a negative number?
No.
No, it won't. It'll get smaller and smaller and smaller. If I cut a half, if I said 2 to the negative second, if I took half of a half, what would I have?
4.
1/4.
A fourth, right?
Can you do negative exponent
Yes. And what it'll do is it'll give you a decimal. It'll say 0.5, it'll say 0.25, it'll say 0.125. It'll give you a decimal. Okay? And you can do that. Now let's go back to our table of values here. So we have y equals 2 to the x power, and I put in negative 1, 0, 1, and 2. When I put the negative 1 in, 2 to the negative first, we already said was a half. 2 to the 0 power equals 1. Anything to the 0 power equals 1. If I put in a 1, 2 to the first, that's 2. And if I put in a 2, 2 to the second, it's 4. Okay, so we're going to plot those on our graph. Negative 1 is at a half. 0 is at 1. 1 is at 2. And 2 is at 4. You're not going to get a straight line. These are not linear. They're exponential. And when an exponent's involved, things either increase very rapidly or they decrease very rapidly. In this case, as we increase our x values, it's going to increase rapidly. It's going to go up. So you're going to make a nice smooth curve. Yours is in a straight line? You might want to check where you plotted those. They're close, but they're not quite. Now, what's happening on the other end of the graph? I asked you the question when I lined up all of the exponents. Will we ever get a value of 0?
No.
No. So what happens on this end is it flattens out, okay, and it's going to keep going. We put an arrow on it. It's going to keep going, but it's going to never touch the x-axis because it never reaches 0, and it's never going to cross the x-axis and get down into the negative y values. So we see this curve. Okay, I'm going to ask you several questions about your graph. The domain. Remember, the domain are the x values. So the x values are in the left and right direction. Is there anything that I didn't use? Can I use negative x values? Can I use positive x values?
Yes.
I use it all, right? So the domain is going to be all real numbers. And I use an R with an extra leg for all reals.
Like negative infinity to positive infinity.
Yeah, you can do that too. So you can say negative infinity, positive infinity. And if you use infinity, remember we use parentheses. We don't use a bracket with infinity. Okay, the range. The range is referring to the y values. So when you think about that graph going up and down, those are the y values. Is it both positive numbers and negative numbers? No, which one is it not? It's not negatives, okay? So we would say that the y values are greater than 0. Would I say greater than or equal to 0, or would I just say greater than 0? Just greater than, right? Because remember, it's not touching this axis. It can't equal 0. It has to be bigger than that. So we would say y's are greater than 0. If you wanted to put that, you could say it's going from 0 to infinity. That's how you want to list it. And again, I wouldn't put a bracket on 0 because 0 is not included. The intercepts, is it crossing either the y-axis or the x-axis? It's crossing the y and where?
1.
At 1, so you could say y equals 1, or if you want to just give the coordinates 0, 1. You could do either one of those. You don't need to do both, but you would do one or the other. Now, do you remember what an asymptote is? Okay, that's a broken line that we use, so that shows the graph approaches but doesn't touch. So the asymptote, or the asymptote, however you want to pronounce it, I've heard both, okay, would be this line. It's horizontal, so I would say y equals And then it's approaching 0 without ever touching 0 or crossing 0. So I would say y equals 0 is the asymptote or the asymptote. We don't have a vertical asymptote here because it's going to keep going to the left, and it's going to keep going as it goes up. It's going to keep going out. So there's nothing that it approaches with stopping. Whereas right here, it's going to flatten out, and even though it's going to get closer and closer to that red line, it's never going to touch it. And then the end behavior of the graph is what happens at the two ends. Okay, the end behavior you're just going to say is kind of like your domain. Okay, it doesn't stop. We got arrows at both ends, so I'm going to describe that as from negative infinity to positive infinity. Remember we talked about end behavior definitely in part 1. What were the ends of the graph doing? Were they both going up? Were they both going down?